How Discoveries Are Made, Thoughts on the Methodology of Scientific Work offers an insightful, albeit unfinished, framework for understanding how scientific breakthroughs occur. In 1960, Genrich Altshuller sketched out his ideas on the methodology of discovery, ideas meant to help organize his initial views on the technology of scientific creativity. Although these drafts were later set aside in favor of his work on TRIZ, theory of inventive problem solving, his thoughts remain relevant today, particularly for educators teaching creative scientific thinking. Altshuller observed that there are inherent difficulties in developing a methodology for discoveries compared to that for inventions. He noted that, in discovery, external factors and historical developments play a larger role, and methods vary significantly across different scientific fields. One challenge is that techniques used for discovery in one era may not apply in another, given the evolution of scientific methods over time. For instance, the methods available in the 18th century for exploring natural phenomena differ markedly from those used today. How can scientists overcome these evolving challenges? Altshuller suggests that recognizing and adapting to these distorting factors is key. He classified discoveries into two fundamentally different groups. The first group consists of discoveries that involve the detection of a new phenomenon, what Altshuller refers to as detection, or the identification of new qualities in matter. Examples include X-rays, discovered by Röntgen, and superconductivity, found by Camerlingonis. These discoveries are often made by noticing anomalies, things that seem out of place. For instance, Cavendish once observed an unusual component in air, an anomaly that, if given proper attention, could have led to the discovery of inert gases like argon decades earlier. How do these anomalies spark new ideas? They prompt scientists to ask why a familiar substance behaves differently under certain conditions, potentially unveiling entirely new phenomena. The second group involves discoveries that reveal new laws or quantitative relationships between known phenomena. Here, the focus is on establishing precise numerical ratios or patterns. For example, Einstein's explanation of the photoelectric effect transformed our understanding of light, while discoveries such as Coulomb's law provided a quantitative foundation for electrical interactions. Altshuller noted that discovering new laws typically requires directed, deliberate effort. Unlike the sometimes serendipitous detection of new phenomena, uncovering new laws often demands a systematic search for patterns and an openness to challenging accepted truths. Could this systematic approach explain why some scientists, like Einstein or Mendel, are celebrated for their groundbreaking work in multiple fields? Altshuller also discussed various methods and techniques used in discovery. One basic technique is to look for white spots or anomalies within already known phenomena. This might involve observing a deviation from expected behavior, such as noticing gaps in astronomical data that led to the prediction and subsequent discovery of a new planet. Another method is to extend the search beyond the known boundaries, such as exploring high-pressure conditions that reveal new forms of ice. More advanced techniques involve re-evaluating established facts from a new perspective. A classic example is when re-examining the principles of respiration led to a revolutionary insight that challenged long-held beliefs about the presence of air in the pleural cavity. Altshuller believed that the creative process in science involves both the discovery of new phenomena and the establishment of new laws, with the latter generally regarded as a higher form of creativity. This is because while detecting an anomaly can sometimes occur by chance, establishing a new law requires persistent, targeted efforts. His work suggests that effective scientific research should not only apply existing theories, but also actively seek out the cracks or limitations in these theories. By doing so, scientists can pave the way for new theoretical breakthroughs that push the boundaries of our understanding. In essence, Altschuller's unfinished draft on the theory of discovery serves as a roadmap for scientific creativity. It encourages us to pay close attention to anomalies, question what we take for granted, and pursue patterns that reveal deeper insights into nature. These ideas remind us that scientific progress is not merely the accumulation of facts, but also the art of recognizing and interpreting the exceptions that lead to new understanding. How can we use these principles in our own research? By combining careful observation with systematic inquiry, we can enhance our ability to make discoveries that transform both our theories and the world around us. Understanding the two types of discoveries, Altschuller's draft distinguishes between two main types of discoveries: those that reveal entirely new phenomena and those that establish new quantitative relationships or laws from existing phenomena. The first type involves simply detecting an unexpected fact or occurrence, while the second type requires integrating known facts into a coherent, explanatory framework. Discovering new phenomena may happen by chance, whereas uncovering new patterns typically demands systematic and deliberate effort, underscoring that true scientific breakthroughs can arise from both serendipity and structured inquiry. For example, an unexpected observation of a new chemical reaction in an experiment represents a discovery of a phenomenon, whereas identifying a consistent mathematical relationship between reaction rates and temperature constitutes discovering a new law. It's like finding a hidden treasure map by accident versus carefully piecing together clues from multiple sources to reveal a secret route. Both lead to valuable discoveries, but one is random and the other is methodical. Recognizing anomalies in known phenomena. One key method for making discoveries is to focus on anomalies, those aspects of a phenomenon that deviate from what is normally expected. Altshuller suggested that even within well-studied areas, unusual details or white spots may indicate the presence of undiscovered phenomena. By systematically examining these irregularities, researchers can uncover new insights that challenge conventional wisdom, requiring keen observational skill and the willingness to question established knowledge. For example, a scientist noticing an unexpected color change in a common reaction may investigate further, eventually revealing a new catalytic process that was previously overlooked. It's like noticing a stray thread in a familiar piece of fabric. Following that thread might lead you to discover a hidden pattern woven into the design. Establishing new quantitative relationships. Discoveries that establish new laws or quantitative relationships involve connecting known phenomena in novel ways to explain inconsistencies. Altshuller emphasized that these breakthroughs often require deliberately testing and combining different ideas to form a new theoretical framework, involving critical analysis and hypothesis testing to reconcile observed exceptions within existing theories. Such discoveries add predictive power to science by quantitatively describing relationships between variables. For example, by analyzing extensive data on planetary motion, a researcher might derive a new formula that predicts orbital behavior more accurately than previous models. It's like finding the missing piece of a jigsaw puzzle that not only completes the picture, but also reveals a hidden design pattern that ties all the pieces together. Considering historical development in scientific methods, Altshuller noted that the evolution of scientific methods over time plays a critical role in shaping discoveries, arguing that different eras have contributed various techniques, and sometimes the transition between old and new methods highlights unexpected anomalies. Historical context provides clues about the strengths and limitations of current approaches, and a comprehensive understanding of past methodologies can guide researchers in refining their techniques to uncover new phenomena. For example, a researcher re-examining classical experiments with modern tools may uncover details that were previously undetectable, leading to fresh insights into a well-known reaction. It's like updating an old family recipe with new ingredients and modern cooking techniques, which can reveal hidden flavors that were overlooked in the original method. Addressing uneven development across scientific fields, Altshuller observed that different scientific disciplines evolve at different rates, leading to uneven development in research methods and techniques, meaning that breakthroughs in one field may occur earlier than in another, even if the underlying phenomena are similar. Recognizing this uneven progress can help identify areas where innovative methods might yield new discoveries and encourages scientists to cross-pollinate ideas between disciplines to overcome these gaps. For example, while fields like physics have advanced rapidly with precise measurement techniques, biology might lag behind, presenting opportunities for interdisciplinary innovation to resolve long-standing puzzles. It's like different sports evolving their strategies over time. One team may be ahead in technology while another has yet to adopt modern tactics, creating an opening for a game-changing play. Embracing the role of chance and serendipity. Altshuller acknowledged that chance plays a significant role in scientific discovery, with many breakthroughs occurring unexpectedly. While systematic methods are essential, remaining open to serendipitous observations can lead to transformative insights, as the unpredictable nature of discovery means that sometimes a random finding can challenge established theories and spark new lines of inquiry. Embracing these moments requires a flexible mindset that values both planned experiments and unforeseen results. For example, a scientist may stumble upon a novel reaction while investigating something entirely different, which later becomes the basis for a groundbreaking study. It's like finding a rare gem while digging in the garden for something else. Unexpected discoveries can be the most valuable. Integrating cross-disciplinary methods. One effective approach to discovery is to apply methods from one field to solve problems in another, leveraging diverse perspectives. Altschuller's ideas encourage researchers to transfer techniques and concepts across disciplines to uncover hidden connections, revealing new phenomena or relationships that remain invisible within a single field's conventional methods. This interdisciplinary approach broadens the scope of investigation and fosters innovative problem solving. For example, an engineer might use statistical models developed in economics to analyze complex biological systems, uncovering patterns that were previously unrecognized. It's like using ingredients from different cuisines to create a fusion dish. Combining diverse elements can result in a uniquely satisfying and innovative flavor. Questioning the universality of established theories. Altschuller's draft ideas emphasize the importance of critically evaluating established theories to identify their limitations and exceptions. By questioning what is considered universally true, researchers can uncover discrepancies that signal the need for new approaches, isolating the weak spots in current theories and paving the way for more robust and comprehensive models. This method encourages a proactive search for factors that existing frameworks do not adequately explain. For example, a researcher might re-examine the assumed constant behavior of a physical law under extreme conditions and discover anomalies that lead to a revised theoretical model. It's like testing the durability of a well-known material under unusual stress. If it fails in unexpected ways, you learn something new that can improve the overall design. Cultivating an inventive mindset. Developing an inventive mindset involves nurturing curiosity, persistence, and the willingness to challenge conventional wisdom. Altschuller's unfinished ideas suggest that true discoveries arise from a deep commitment to uncovering hidden truths and a readiness to embrace radical new ideas. A mindset built through systematic practice, interdisciplinary collaboration, and reflective analysis of both successes and failures. By focusing on the process of inquiry rather than immediate results, researchers can achieve breakthroughs that transform entire fields. For example, an aspiring scientist might continually refine their approach to solving a persistent problem, using each setback as an opportunity to explore new angles until a breakthrough is achieved. It's like training for a marathon. By steadily increasing your distance and adjusting your strategy based on each run. You build resilience and adaptability over time, leading to eventual success.